Oh, it's way better now. Thank you. So then I did a 1 year master in France, and then 3 year PhD on ways in France. And uh, at the output, I started working for Safran Group, a Safran Language System company, from 2018. And 2 years ago, I became a company expert in electromagnetic devices. So yeah, for your information, we have like engineer grade, and then company specialist, and then company expert. Well, the company expert doesn't is not necessarily someone who knows every machine, who masters the, how to say, the every softwares and tools, but he is the, how to say, the reference of the company for most of the electromagnetic questions, because each company has its own interest in electric machines. So today I would like to present about the electric motors and machines activities of the group in general, and of the company in how to say, in details. And then I would like to discuss with you how the company um, do the motors from design to manufacturing. So the next slide, please. I present quickly the group. Safran Group started from 1915. Firstly, it produced only the, how to say, the engines for the aircraft, and then it developed. It combined with many other companies to extend the product, to extend the applications and the in the field. So today, it works on a 5 main field: aircraft equipment, for example, the landing gears system, the how to say, the flight control system, even the cabin, the seat in the cabin, the ventilation system in the cabin. It works in the aircraft interior. So as I just said, an aircraft propulsion. You have two types of propulsions nowadays: the thermal one, the classical one, and the electrical one. So electrical one is interesting, and we will talk about it later. And defense, in the defense field, for example, it produces the UAM, the different electronic devices, and it cooperates with Airbus, European Airbus, in order to explore the universe, so space industry. In the next slide, I will zoom in. I present quickly some applications in the group. So you know, in the landing systems, we have so many parts, so many actuators. And traditionally, the actuators are hydraulic actuators. It means that we have the pilot controls, and then there is a hydraulic circuit that will actuate the different equipment. Here we have the braking actuator. So you can see the disc. So those are the carbon disc, very famous carbon disc used in big aircrafts, and even in the Formula One racing cars. And in the old version on the left, we have like 4 hydraulic pistons that push the carbon brakes when we want to brake. But now we are replacing the hydraulic systems by the electrical systems. So on the right, you have the electrical equivalent version. So the same carbon brakes, carbon disc, but you replaces we replace the hydraulic pistons by the 4 electric machines. Well, with the pistons stays the same, but we replace the hydraulic circuit by the electric circuit and some small electric motors. So as you can see, we need to do something. Well, the first criterion in aeronautic industry is to make it small, to make it compact, and to make it light. And we even have more to make it reliable. So don't hesitate to ask the questions right away if you have it. And maybe you already know. So the secret, well, it's not a real secret, but the technique that we usually use to make the motors smaller is to increase the gearbox ratio, right? So from the rotation to the translation of the pistons, we have a transmission, and with higher transmission ratio, we have smaller motors normally. So that's the point. However, with higher speed, you know clearly that we have more losses and like reliability questions on the bearings and so on, and vibrations also. And in the next, yep,
I
go
have
ahead.
small question here.
Yep.
So from it's very clear the model from your design from your side is really in critical application. So what is the most priority in your design problem, about reliability or about the efficiency?
Well, the efficiency is the last. Because in this, yes, because in these applications, for example, the braking, the aircraft brakes only within 30 seconds to 60 seconds, and the motor, each motor is like 2-3 kilowatt maximum. So they do not consume a lot. So what we need is the lightweight, small volume, and good, very high reliability. So the three criteria, the three most important criteria: weight, volume, and reliability.
It's possible to ask you about the density now, from the how many kilo per
the torque density and the power density?
Yes. Can you say something?
Well, so all these motors are SPM. Normally they are SPM, and we have natural convection. So the torque or power density, if for the brake motor and for the, how to say, the pump motor, they rotate quickly. So we have like high power density, but not the torque density. It's quite low, and we have like natural convection. But in the next applications, we can reach up to from 25 to 30 Newton meters per kilogram. So that is not impressive, I know. But then the first reason is the natural convection, and the second reason is we focus more on the reliability. Why we accept like traditional manufacturing. Traditional manufacturing, we don't have like advanced, so advanced manufacturing, but it should be reliable and certified in the industry. So that's the most important part. However, my colleagues, they can reach up to in the group 70 Newton meters per kilogram with oil cooling. So that's much higher. So in my company, we have like 25, 30. And in the other company, 70. And we talk much about the torque because the power is not that, well, the speed is not that high in our applications. You will see later. So here, so the motors start to be big. Here, you can see that there's an aircraft. Do you know when the client, the passengers already got into the aircraft, and then what is the next step? Can the aircraft, how to say, reverse into the runway, or does it need some help? You may not see when you're already in the cabin, but the answer is the aircraft can reverse itself by its motors, but that is not efficient. It's not very efficient. So we can call the service, the crowd service, to use a pushback tug in order to push the aircraft into the runway, and then the aircraft will run itself by the how to say, the main motors, engines, to accelerate and to take off. So the idea here is to replace the vehicle, the crowd vehicle, or the using of the engines, the main engines, for the reversing, for the pushback. So we will put two traction motors inside the two main wheels. As you can see, it is in the blue color. And you have from the motors to the upper blue color, it's the APU, the auxiliary power unit. We don't have battery here, but we have the, how to say, a generator that supply directly the motors through the power electronics. So this is the system. And for example, each motor is 25 or to 30 kilowatts with good efficiency, 94, 95 at 150 degrees Celsius. Well, so it's 20 degrees Celsius, it's higher, 97, 98. And the next, well, so we have a quite big, and the most recent one, we have like propulsion motors. As you maybe already heard on the media, that Safran Hatches certified the propulsion motors here for the aircraft applications for to replace the thermal engines in the long term for the drones, for the UAM, etc. And the power is from 50 kilowatt to 1 megawatt. So even for the big aircraft like the Airbus A320, it can replace. But the bigger question is the battery. The bigger question is the battery, the energy source. As you can see, the powers of the voltage supply is higher, 850. Well, the purpose is to reduce the current and to reduce the losses, as well as the size of the component, the conductors. And the speed range you see is not that high, 1500 to 4500 RPM. So quite like a direct drive. But the hard part is to make it reliable. We have many solutions. In traditional motors, you only have one star. Here you can have many stars, many windings, for example. So those are some examples. And in the next slide, I would like to talk about how we do the motor in the group or in the company. In short, so firstly, you have a target aircraft or a drone, for example, and the client here, for example, Airbus, Boeing, Hyundai, or even the Chinese Comac, they will say, okay, I would like to have a e-taxi function or the propulsion motor, and the speed and the weight of the aircraft is so on, or so on. So, and we have, and it would like to have the functions. So, okay, Safran accept that request, and in a very short time, they need to discuss together to see, okay, for this request, we can propose such system architecture. And from the system architecture, we will define the specification for the motors. So what we need to design the motors, the voltage, the maximum current, the maximum power, and the maximum torque, maximum speed, or design efficiency, design power factor, etc. And the powering point, even the lowest and the highest temperature. Okay, so with that, our job, well, my job is to propose different topologies. If the cost is also a criterion, we can think of different topologies, or the cost is not important, we can use the permanent magnet motors. So design from topologies to the details with multi-physics, how to say, iterations. So as an EMAC engineer, we work a lot with the mechanical engineer. For example, we don't know if in such, with the current technology, we can reduce the air gap up to 0.2, 0.3, or we need to, because we have very like shocking in the aircraft, we need to keep 1 or 2 millimeters. So that is important. The thermal engineer, we need to see if the initial temperature is 20 degrees or even hotter, 100 degrees already, and we cannot, well, with the traditional technology, we cannot exceed 240, 220 degrees Celsius for the windings. And the manufacturing is the very, very important part. What differentiates from, I think, from industrial motor and a student motor, let's say, is the manufacturing. Because the design can be the same, but then the manufacturing will impact everything, the reliability, the efficiency, and even the size and the weight. Don't hesitate to ask for more details or examples. And then finally, we test the motors. We integrate it into the equipment, into the aircraft, and we run so many tests. There's so many different levels to test. And as I said before, we do a prototype, many prototypes first. We have some prototype tests, and then we do the serial production later, and we have higher requirements for the serial production motors. So that's it. So the role of an electromagnetic engineer is everywhere. So at system level, very high level, you will participate, okay? Because they have a very large vision on the system, the architecture. They can be a mechanical engineer or electrical engineer, but you will tell them, okay, if you choose that, you will face such difficulties or such advantages. So you will give them the elements. So when they build a specification, so yes, you can participate also. Normally just to listen, because from the architecture, normally you will have the resulting values. For example, you know that the aircraft, the network is 400 hertz, 115 volt RMS, and 400 hertz. So do you want to use it directly for the motor design, or you need to have power electronics in order to convert it into like more traditional power supply, 3 phases with variable frequencies and 400 volt DC, for example. And design and the manufacturing. Yep. Design and manufacturing, you do it manually, and then you participate also in the test and integrations and runs and so on.
I think now time for question. Is there any question from audience, please?
Yep.
I have no question, but no, not technical question. But Ming, I see in your old presentation you say confidential. Are you aware that this webinar is recording and it will be published on VPEC YouTube channel?
I didn't change the C2 confidential, but no worry. These informations are from the public website of the group,
Okay,
so
okay.
there's no problem.
Okay.
I just cannot change the C2 confidential. C2 means it's for interior discussion, and
Okay.
C3 is only for some people in the company.
Okay.
Understood. Thanks.
Any question from audience, please?
Is Han speaking? Actually, it's also the North question. I'm just sharing the what is the challenging the same challenging we have done before because before when I'm still working for Nidec, one of the project is the okay to develop the one very compact electric motor for the drone, and we facing many challenging to balance between the power density and the thermal performance. And at that time, actually, with the very high power density, we even need to using the direct cooling methods. But actually, it failed the project. So I quite impressed with what the Safran can do with the even bigger application. Yep.
Well, the product cycle, the product life in aeronautic industry is quite long. 10 to 20 years of development. I know that in automotive industry, it's quite short, 3 to 5 years. Which was the application when you worked for Nidec? There's a joint between Stellantis and
No,
Leroy
just
Somer.
that. Oh, okay. No, it's a drone. We're making a drone, and
A
it's
drone.
just for the
Okay.
logistic. Yes, and
Okay.
it failed. Sorry.
Yeah, but well, we learned from the failure. So, for example, the e-taxi, well, to move the aircraft on the ground, we have developed since 20 years, for 20 years, through 4-5 generations, and it's not flying yet. However, the propulsion motor is flying, is certified, and it's already flying on some small regional aircraft.
Any more question from audience? If not, we should move to the last.
Me, please.
Okay.
I mean, same question with Victor before. What is job opportunities in your company, Ming? Because I know there are many people are listening to you and also feeling interesting about the job opportunities after their graduation.
Okay, so every year Safran take a lot of create a lot of post positions. Firstly, for the internship students, most of them from Europe, but then very important parts of them from, for example, the other countries like Brazil, India, Vietnam. Sometimes because in some special programs between the two countries. And then after the internship, normally they would take the student for the permanent positions. there are less positions, fewer positions, but they do take the internship student. But in my case, for example, I did I did a PhD first, because after the master I found it extremely difficult to enter into the industry. So I told myself, okay, I will do a PhD. It's interesting. I will see how it works in academic world. I will have opportunities to go abroad for in the conferences and in the internships. And after that, okay, I experienced, and now it's time to work in industry a little bit to see if I appropriate. It's a good match for me. But believe me, with what you've learned, what you have gained in PhD is very, very, very precious, and for the industry, for the even aircraft industry, and it will make you it will give you like the advantages, a lot of advantages to go further in the career in industry. So don't hesitate to do PhD first, and if you can do it in Europe, so that you can apply easily for the European companies. But I know that the master student from Korea, Europe, European companies and schools really like the master from Korea, because they know that the student worked very hard, and they have very good foundations in the field. But in order to enter the industry, it's better to do something first, a PhD or another master in Europe, as an advice.
Yeah, I think that is a very good point. Because the most students work in Korea or Taiwan, they work very hard. But the main problem to get into Europe, that is communication. I think when students they have been trained with communication in Europe, and it's very easy to get into the company. Anyway, I think we should move to the last presentation from Dr. Hai from VinFast.
Okay, thank you. I'm sharing my screen, and
Yes.
please confirm when you can see my screen. Is visible for the team?
Yes.
Okay.
Very good now.
And I am the last one, and with the longest presentation. And but I try I try my best to shorten. And thanks so much for VPEC to give me the chance to introduce about the VinFast, about my team, and also some activity. And I'm bring to this today is a topic is a optimization strategy to balance cost, efficiency, and use of the energy water for next generation of VinFast powertrain. It's a very long title, but I will take this chance to again to introduction about the VinFast and also my team. I think the VinFast, many people here know about the name, but how it in detail, I will give some very quick summary to the team here about the VinFast on my team, and I will walk the team through this kind of the research, but very quick. Um, and of course, at first, I would like to introduce a little bit about myself. I joined VinFast from 2018, and currently I'm in charge of Director of Mechanical Design Center, VinFast Inverter R&D Institute. So I lead the team of about 25 members, responsible for 5 products, 7 vehicle program, already applied on more than 1,000 cars and more than 10 markets. And before joining VinFast, I have about actually the 13 years study master PhD in Taiwan and also the working in Taiwan. And before joining VinFast, actually I'm work as a researcher for NIDEC R&D Center in Taiwan. So it's a very brief about me. And about VinFast, actually VinFast is a part of the Vingroup, and one of Vietnam. Actually, not one of. Right now, we are the largest private enterprise uh, in Vietnam, and many people remember or know about Vingroup is famous for the Vinestan Resort shopping mall, but actually we are already have changed the direction, and now we also focus on the technology and industry. And a little bit about the VinFast. Actually, we are just established very young guy. We established in the 2017, and actually we have the factory in Haiphong, and at the beginning it's just empty. It empty, really empty land. And only 2 years we already complete the phase one, the facility in and starting to mass production the vehicle. And we also we firstly focus on the internal combustion engine, but it also one of very few um, vehicle or automotive OEM to cancel or terminate the internal combustion engine and focus on the electric vehicle. And as a result, about the 2021, we have the first EV run off on the production line. And around 2022 and 2023, we also have the first shipment to US or the North America. And how quick we are here is the own product portfolio. What already on the mass production, you can see that is from very small one, A0, VF3, to the very big one is the VF9 E segment. And we not only focus on the Vietnam market, and we also go globally. And we are one of very few EV OEM can have the full range of product like this. And thanks for the many effort from the own the VinFast and own the Vingroup. We already become the top one in Vietnam market and the top number 8 in the global market. So that is the very big motivation for a young company like VinFast, and also own the um, member to take a part on this kind of history. And actually, we are not stopped at that. We also continue to develop more model, and all of this model showing on the screen here will be launched by end of this year and also the early next year. Okay, so that is the VinFast. And how about us? VinFast E-Motor R&D Institute. So very here you can see that what we are responsible for. The EV, we know that the heart of EV is a traction motor, or we call it the electric driver system, including the e-motor, transmission, and inverter. And we name it with the EDS. And our team work simply as the internal supplier for this product for the whole VinFast vehicle program. And actually, it's a little bit different from the other OEM or actually the ODM, like the ABB or Safran or even my previous company, NIDEC. Our engineer actually work in very wide scope from the design and also to the manufacturer, or even me myself, or also sometimes need to directly work with the customer side to explain some issue happen on the field. So we are very dynamic and also need to responsible for the very wide scope. And what is the product we already work is the screen showing all the product we have working on. The first one we call is the EDS 1.1, is a SOP in 2022, and so far is applied for the VF 8 and 9. This one actually is still using very traditional conventional technology like the raw wire wiring, or water cooling, and and just after 1 year, about 2023, our team is the develop and SOP the next generation. We name it the EDS 2.0, and we already applied the Happin technology. And so far it's applied for the VF 5, 6, and 7. And we also have the one advanced project before and stop at the example. His name is the 3.0, and with the 800 volt system and apply the many advanced technology in the traction motor like the silicon carbide motoring, oil cooling, and using the planetary gear system. But this is the stop at the example, and it have chance to reborn in the next platform of InFAct. And actually, during the meantime, we also have some upgrades. Developers the very small one for the VF3. This one actually at the beginning is developed for the aero market, but right now in fact it's put on hold the aero market for VF3, so it's the terminal temporary to put on hold. And we also have the plan to upgrade the EDS 1.1 from the raw wire technology to the Happin technology, and it will be SOP actually by end of this year. And to do all of this thing, actually, we have very strong. Also, actually, we try to develop our own R&D capability from the system level to the module level, and also the own the testing system. I would like to talk a little bit more about the testing system because at the beginning, Professor Kang mentioned about how to ensure the reliability of the product is very, very important for this kind of the automotive application. And we have the very complete system, test cell system, to cover the more than the 1,000 test cases from the vehicle level to the system level and even the component level. And we need to ensure about the product should be functioning in the 10 years or equivalent to the 300,000 kilometer. And actually, this kind of standard is a little bit outdated because I'm talk with the OEM in China very often, and now they are already increased the lifetime of the product even up to the 350,000 or 400,000 kilometer already. So the requirement from the automotive industry is the increase more and more. And this is our testing system. And we also not only as I just mentioned, not only the system level, we also the module level focus on the power electronic part, or even on the vehicle level. we also have the very complete testing system. Okay, so that is the all about the VinFast and the Vin group, and also our team. And I go to the background of the research, this research optimization. And actually, this this material I'm prepared from last year, and is not outdated yet, and it even become more critical this year about the cost down, about the new product launch speed. So this is a fact. This is happening in Asia, and VinFast as the very young company, and if we want to adapt, we want to survive in this area, we need to also find a way to catch up with this kind of requirement. So let's say about the requirement of development, we always have the consider about the between performance and from cost. Okay, everyone, I mean, all the boss want to have the good, I mean, good performance. But if the good performance is always come with the high BOM cost, and if we go with the low cost, it also very difficult to maintain the good performance. So what is the balance point? Is good high performance and optimal cost is the requirement. And in the development, if we want to have the complexity less, so the accuracy is also not good. And what is will be fast? It will be calculated fast. But in the more detailed design is when we have the a little bit medium about the complexity and also the calculation speed. But the most complex one is the 2D or multi-physics, but it's always very slow. So the research here, we try to find a balance point between the performance, one cost, and also try to consider all of these things right at the feasibility phase and with a certain level of accuracy. And of course, we always need to consider how to calculate it as fast as possible. Okay, so uh, many points need to consider, but what is objective of this very specific objective of this study? Let's say about our ADS. So it will be including the many parts like this. But we look at the BOM cost ratio between the part like either the motor side, transmission side, and the inverter side. And in this study, we more focus on the e-motor side, and we try to optimize the performance and also the BOM cost of the e-motor. Okay, so what is the methodology we have done? Firstly, we try to develop a platform for the study. I think all of the researcher here who familiar with the electric machine design, we know about the analytical calculation. We can use the kind of the theory formula equation or the some commercial or even the open source calculation. It's quick, it's very quick. Simple, low investment, but of course the accuracy it will be the question. And we also try, if we want to using the something more accuracy, we can use a hybrid like analytical and ADA final element like the Motorcad, and it will be the take a longer one. And it seems simple, moderate investment cost, more accuracy, easy customer, increased number of options, but it still have some drawback. And of course, the last one, using directly using the 2D or 3D, it will be take a longer time, of course, but it will be help us to get more accurate result. So what is why are we thinking how to utilize on the pros point of the owner of this method, and we select the MotorCAD for the solver, and we using the optimization based on the ANSYS of this land. And what is the main contribution here? We try to create a Python with the many kind of the user-defined function to connect these two to um, to optimize our product with our requirement. So that is the platform for this study. And for on the development flow, I will very go very quickly. Even we have about the 4 steps. The first one is the sizing, sensitive analysis, optimization, and validation. And each of the step here will be the have the different implementing time. And we have run one. We already have one and study, and it takes about the 48 hour to get up to for 100,000 design, and can give us the some option, and we select the best one to validate the design. Okay, so the is the on the development flow. And for I will go very quickly for the H1 for the siding on the electric motor. The researcher or designer know about what we need to put on the siding, but it based on the design input from the vehicle performance, vehicle working environment, and even some constraint on the production line. And we create the range, design range for the own dimension, and we put it on the script and create a user function design, user-defined function, as I mentioned at the beginning. And one of very special or more important in this script, I want to focus on the two things is one cost. Actually, this one is very critical for the industry or the OEM, like in fact like us, because we are need to know about the BOM cost right at the beginning. So we consider all the factor will impact with the BOM cost, and we put it in our script. And the second one is about the NVH. The MotorCAD actually they have the one tool to support it to do it, but we want to make it in kind of the optimization process. So we create a script to collect all the EM force, and we put it extract it into the optimization process to to optimize the NVS of the machine. And after that, we run for the first sensitive analysis with the 300 design, and to see that it with all the constraint, all the range is feasible or not. So if have the result, it means that it's feasible with all the constraint we get at the beginning. And the next one we can define the deeply more analyze to see that which is the critical parameter to impact with the performance of the e-motor. And the last one, we will run the optimization process to get the option to some the option in between in consider between the performance and also the BOM cost. And we also in it also have the consider the trade-off between the efficiency or the performance is on the BOM cost. And we have select some most potential candidate to do further validation. And it's a validation, we can go directly with the 2D and 3D to um, to do the design validation. So this is the whole process. And what we have applied for this method, actually we focus on the EDS 1.1. This is the spec, and at I mentioned at the beginning, this one is still using the very conventional round wide technology. So it has some disadvantage, like it's still using the conventional wiring technology, and it also have a lower capacity, and it need to improve and apply exactly the same, exactly the methods I introduced. We consider about performance, NVS, and BOM cost, and run using our study platform to do the optimization. And according to the after run through all the analysis, we can have the many option between the uh, like the selection about the magnet, about the air gap, or the if copper loss, or the EM force, and it will be reflect into the efficiency, ripple, and EM force here. And we in this study we using the current round wire as a base, and we compare with the we select the three candidate uh, using the hairpin, and compare on the pros and cons about what is the performance we can reach, and the cost we can save, or efficiency we can increase. um, so in this study, we select the first one, the second one, where is we get the most balance between the we still have the better efficiency, also the overall we still have the better cost, and also the if the NVS performance. So that is the uh, result of this study. And we also apply the same methods for our second generation 2.0 here, and also apply for the 3.0. And the last one, actually, we're talking about the round Y and the hairpin. Actually, is not new, but for the VinFast, as you can see, that is only around 3 years. We already uh, um, changed from the uh, very conventional technology to the more advanced, and it also our direction. Uh, we can continue to apply the hairpin technology, and it's have some new technology coming like the wave hairpin, uh, now dominated by the Sapler, or the some X pin or W pin is developed by the China ODM, and VinFast will be applied all of this new technology for the our next generation of the product. So for the last one, okay, just very brief summary. In fact, very young, but we dynamic, and we have the try to find a different way to catch up with the technology of this area. And as a part of this, our team also try to do some our own R&D to have the sufficient process or tool to make uh, the motor design with very quick but reliable and and efficient. Uh, in terms of development. Okay, so that is all my presentation. Thank for keep patient to hearing. Yeah, thank you.
Thank you very much, Dr. Hai, for your very impressive presentation. And we have learned a lot from your presentation. I think now it's time for question from the audience.
I have one question.
Please come.
Yes.
As you know, the automotive industry is facing the how to say the rare earth magnet shorten. Sometimes it's a famous problem now. So what is your strategy to prevent this the risk?
Okay. So thanks for asking. Actually, we already consider it, and we have the two directions so far, and it's also the ongoing. The first thing we will try to develop some kind of non-rare earth magnet, like the synchronous reluctance motor or the external exciting rotor synchronous motor EDSM. So this is the one direction. And the second one actually is more like the application, because right now even China, the biggest manufacturer for the rare earth magnet, they also have some new technology to develop kind of the low heavy rare earth element magnet. So we also try to think about using such kind of the magnet into our product. So that is the direction.
Thank you. And one more quick question. Do you do everything from A to Z for your motors, or you still need to, how to say, subcontract to the partners? Well, I mean the other partners outside Vietnam.
I actually, for the first generation, I have to confess that we based on the technology transfer and also work with the one very famous partner in Europe to improve, upgrade the design. But from the next generation, EDS 2.0 and the 3.0, we do own by our own. Yeah.
That's good. Great to hear. Thank you.
The next one is Tip.
Okay, thank you so much for the presentation. I'm Tiff from Hanoi University of Science and Technology, and I have three questions. First,
Wow. Okay.
You mentioned about time lifetime. So, can you ask about the how can you calculate the lifetime, or how can you calculate the MTBF of a product? The first, and the second question is, the second question is, do you make the DFMEA report for to manage any problem during develop product? Please sharing about the how can you make the DFMEA report? And the final question is regarding to the fault error in diagnostic. So can you how can you manage the fault in the large system such as the car and all the charging? Yeah, thank you so much.
Okay, so I repeat about your three questions. The first one, how to calculate the lifetime, right? And the second one is how to consider the DFMEA. And the third one is how to handle the phone and diagnostic. Okay, so all very key, very, very, very key, the question. And in fact, it's all the know-how of the ODM. And I have to say that I really want to share. But please join us, and I share on the answer. But let's say like this. I can give the very brief and general an answer for you about the lifetime. Actually, it's very complex calculation, and is based on the firstly we need to targeting what is the market targeting, and we base on the let's say the driver cycle in the target target market to collect all the data of this load from the load cycle for that driving cycle, and based on that kind of the load cycle, we do very complex calculation to reflect the damage for some critical part like the bearing, like the gear, and based on this to see the under which kind of load and the speed it will be create the damage equivalent to the, for example, 10 years of working or the 3,000 kilometer, the 300,000 kilometer of the operation. So this is really complicated one, and you can file the hundred or thousand of PhD dissertation to talk about it. Really complex. And for the DFMEA, actually, it's also the same thing because there is the know-how of the OEM, and it's really based on the what would really happen on the field to update, because the DFMEA actually is kind of the living document. It's not a fixed. We can have a very fixed one, and collecting, communicate or cumulate on the issue we happen during the operating on the field or on during the manufacture. We update it continuously, and it will be make our product more and more robust. And the last one about the phone diagnostic, it also very important point, because it's a key for us to do the root cause analysis if it's something happen on the field. And it's the reason why the in automotive now, if we are study, it will be develop the software or product need to follow the standard of the ISO 26262. And our product, VinFast product, already achieved the ASIL level C for the safety level. So we need to have many protection function to prevent all critical issue can happen on the field. But again, if you have chance to join us, you can know in very detail how to do this.
Yeah.
Okay,
Thank
so
you.
much. Thank you for sharing. Okay, thank you.
So the next one is from Mr. Tung.
Tung, I think you are in mute. I cannot hear you. Still cannot hear you. I don't know about another one, but I cannot hear too. Anyone can hear him?
No.
Nope.
No.
Can you tie your question on the chart as well if you want to? I think when we can move to the next question while waiting for him. Okay, next one, Trung.
Yep. Thanks anh Hải lần nữa. Very interesting presentation. So I have two questions. First one is about the BOM calculation. I mean, I never done it before, but from the graph you shows, I only see the material cost. What about manufacturing and labor cost? Is it possible to include it into your calculation? That's my first question. The second thing is the same as Ming before. In one of your slides, I see something say confidential. Is it possible for us to publish this recording online? So, yeah.
Okay. Firstly, related to the confidential, let me try to review again the material. But I think the 99% is published. It can be published, so it's fine. But I will review again before confirmation to you. And about the bomb calculation, you are right. But we are separate. Actually, we are separate the manufacturer and labor cost, and we leave it into the factory side, because when we put it in that calculation, it may be more complex. So we just focus on the material cost here. And in fact, the material cost, we also need to update with the variation on the market. So even the engineer, we also need to have the very close communication with the purchasing team or even the supplier. We also talk directly with the supplier, so we try to get the latest material cost. Yeah.
Understood. Thank you.
The next one, Khan.
Yes. Thank you, Mr. Hai, for interesting question. And I am Khan, and a PhD student in the KARI in Korea. And I just have just small question. And when I see documentation in the page 12, I just noticed that the VF7 had the bigger size on the VF3, but you use a smaller power rating power. So can you explain why? And I see you mentioned using the oil cooling technique. So can I ask which oil spray cooling technique you are using and which part of motor you are focused on oil to oil spray cooling? And final question is the EDS 3.0 mode EDS 0. EDS 3.0 version. Did you try to do at the 800 volt, but as a motor is a 400 volt? So can you just tell me the reason why? Thank you.
Okay, so let me confirm. We have the three questions. One is about the power for the VF3 and VF7, right?
Yes.
And the second one is about the oil cooling system.
Yes.
And the third one is the 400 volt versus the 800 volt.
Yes.
Okay. Here actually I think I need to clarify this. The VF7 actually they using is an all-wheel drive configuration, and it's using the two EDS. One is the front and one is the rear, and it's using the two EDS, the 2.0, and it means that the totally power is up to 260 kilowatt. And for the VF3, in fact, it's very small one. And if this version is it can go into the mass production, it's only up to 50 kilowatt. And but for now, in Vietnam and the Southeast Asia market, this power for VF3 is only the 35 kilowatt. Okay. So probably my presentation creates some misunderstanding for you, but the VF7 is the also very big one. I mean, very powerful the ED. Okay, and the second one about the oil cooling. Oil cooling here in the EDS 3.0 actually is one of very product we very proud. Even it stop at the example, because as I say, it already adapt many new technology. Oil cooling. Oil cooling here is many part. It needs the oil cooling. Firstly, is the stator. With the stator is also have the inner oil cooling. Is mean that the the oil channel. We have the oil channel. We go through the stator, and we also have the mechanism to spray after they go to the stator part. It will be go to that channel and spray into the end winding. And that is not only the part of the oil cooling, it also the have the direct channel to cooling the bearing system, and it will be combined with the lubrication system of the transmission. So on the transmission lubrication and the stator rotor here, it also using the same oil system. So that is the oil cooling system for the EDS 3.0. And for the 800 volt and 400 volt system, actually we know that or why we need to why right now the EV they are tending to the 800 volt system. Mostly it will be the zone, the one of the disadvantage of the 400 volt system is the charging speed, and is the most important reason. So right now we are always talking about the super fast charge, and it should be the charging is less than 10 minutes or even 5 minutes. So it need to go to with the high voltage system. Otherwise the discharge current is a super high, and the thermal system or the cooling system cannot suffer this. And of course, one of the um, uh, advantage for the e-motor itself is the efficiency. If you are working in the e-motor design, we also know that if we can have the more input voltage, we can have some advance in improve the efficiency. So this key point is the reason why we go with the network system. But it also has the drawback. The drawback, first of all, about the power module. I know actually the first thing is the insulation system. It will be the higher than the portable system, and so it increase the BOM cost of the motor. And the second one is related to the power module. Now we're using the IGBT power module, and it will be the cost is become lower and lower. But for the silicon carbide, it's still high. So you can find that currently the 800 volt system is still for the high performance. I mean higher higher cost car. And it also one limitation that to build the charging system with the high voltage system, it also requires a huge investment. So this is some drawback of the 800 volt system. But the trending now for the whole traction motor or EV is going to the higher, because the power module is become lower and lower, and the forecast from the OEM actually, it will be starting to decrease significantly from the 2026. And the charging station actually for VinFast it's our advantage, because the charging station is developed by our own. So if we can dominant in the charging station, we also have the better sell in the targeted market. Yep.
Thank you so much for interesting answer.
Okay.
So I just one small point thing I want to ask is, for example, in the
Okay.
EDS 30 for example, so 95 kilowatt is a 95 kilogram is a weight, total weight of the motor and driver system and cooling system in the picture here. Is it correct?
Yes, and actually it also not the final our target, because our target is about 80. So for the power density, it's been about the 3 point something. So we really want to make it become the more competitive in terms of power density. But because it's just an example, so it's still big.
Yeah, thank you so much. Thank you so much.
And now more question?
Hello, can you hear me?
Yes, now we can hear you, Tung.
Yes, thank you. So hello, Dr. Hai and everyone. My name is Tung, and I just graduated a master degree from Kerry, same as the place where Dr. Zhou Chung got his PhD from. And I would like to have a question for Dr. Hai. So yes, so a common opinion that people have recently is that even though EV or electric car in specific has been growing in recent years, but they are very worried that the trend might have been stagnant. It has stopped growing. So as someone who worked directly in the industry, do you feel that the demand for electric car has declined, or it has still is still growing very good right now? And also, what do you think makes the VinFast car better than other competitors on the market? Those are my questions.
Okay, very straightforward question. And I think it also the query is not only you or owner of the even our member, because we are work for VinFast here. It's not only for a job. We bet our career on this. You can see that I'm already work in Taiwan, live and work in Taiwan for the 13 years, and I back to Vietnam, and I bet my career on this area, on this field. But back to the fact, okay, about the EV. Of course, it should be showing by the data. I cannot show here, but I have tried to look at all the data from the team, investment team, marketing team, and also the own my partner in China and also European. The EV is still the trending, and let's say like this, especially for the Asia and the new market like the Southeast Asia, uh, uh, eh, Southeast Asia, India, and the Mid East. You can see that look at the population in this market. India is more than 1 billion. Indonesia is the I think the 300 million. Mid East, Vietnam, all the Southeast Asia. So only you need only focus on this cars, this area, this market. You already dominant about 1/3 of the market share. So all of this market, it is a new market, and on the government in this market, it aiming for the green, the green industry. Especially you can see in Vietnam, right now the very strong policy action from the Vietnam government to make the Vietnam greener, and it also the same for India, Indonesia. So back to the main point, EV is still the trending. And I believe that I think last 2 years I also have chance to attend one conference in Berlin, and in fact the European is one of the country the motivate the most for this kind of the changing. The only thing that they have the many conventional internal combustion engine here, and the changing is will be a little bit slow, and the same for North America, but they still the changing is not stopping. So it will be the is I think the main point. Okay, and come to your second question. Sorry, can you repeat again?
Yes. So I just want to know, what do you think is the advantage of VinFast car compared to other electric
Mhm.
car companies like Tesla, BYD? Yes.
Okay. So let's say like this. If now we're talking about the core technology, we cannot compare with not only the Tesla, even compare with the China. We also cannot compare. And even the BOM cost, even we do many activity, but you know that the raw material, the very important raw material or in critical part, it also cannot defeat China. So in terms of the technology and the cost, we have the many drawback. But what is the make the VinFast is successfully so far? So far is about, let's say firstly about the service. We have the extremely good service, and it will be the very special service, and it not like anyone else. And it is create a kind of a new how would say a new standards for the service in the automotive area. And it can be supplied for all our customer in Vietnam and also in other market like North America or European. So these are the service. And the second one, it also about the uh, very smart strategy from VinFast side. For example, we using the leasing. We using the leasing the battery strategy, so we can give the customer to have the car, to own the car with a lower price. Because you know that for the battery, it costs about the 50% of the BOM cost for the whole car. So VinFast now we take that risk. And the risk here is also about the investment. It's also about how to recycling on of this kind of the battery. But now to create to how to say to win the customer, we willing to take that risk. And you can see that this is what we are trying to do now, and we can also continue to improving it. But we, as I showing on the presentation, actually, we also have the new platform coming, and that on the platform we try to adapt with new rich technology in this area, so we can gradually to improve our competitive in the core technology.
I think
Thank you.
we should
Yes, that was a good answer. Thank you.
thank you very much, Dr. Hai. It's very interesting presentation and very detailed response on the question from audience. We really appreciate that. I think the time is up now. We should close our session today. Thank you very much for your contribution. We hope to meet you again in another time. And of course, we hope the opportunity to open up a new collaboration if we find some common interest in research or, let's say, development. Thank you very much.
Okay.
Thanks
Thank
a lot,
you.
everyone. Have a nice weekend. Bye bye.
Have a nice
Bye-bye.
weekend. Keep in touch.
Yeah, thank you very much.
Okay. Bye bye.